What's the highest technology in your life? The internet? Your smartphone? Your car? A jumbo jet? In this program, I've talked a lot about advanced technologies such as thin-film photovoltaic panels, electric vehicles, loop and hyperloop transit, and the artificial intelligence that makes a lot of these things work more smoothly. Now, don't get me wrong, these are all impressive, but compared with the technology we'll be getting into today, the sum of all human invention barely registers as a speck. There is a much higher technology. It's all around us. And we'll need to understand it if we want to build cities that can heal the world and create universal wealth. Cities, designed like modern Edens, for economic and ecological abundance. I'm Kev Polk, your guide to Edenicity. Welcome to episode 13, where we'll discuss the Edenicity of the most advanced technology in the world. Yes, that's right, I'm talking about soil. But before we get into the details, let's dispense with one thing. You may have heard of this thing called the Singularity, the idea that technological progress is growing not just exponentially, but asymptotically. Now, asymptotes, as you may recall from grade school math, are those lines where a function blows up to infinity in a finite amount of space. For example, 1 over x goes to infinity as you approach 0 from the right. There are actually very accomplished people in technology who firmly believe that before long, the pace of technological innovation will hit an asymptote. This means it would go to infinity in a finite amount of time. Well, how would that work? The usual story is that it would involve some convergence of artificial intelligence, direct brain-computer interfaces, and nanotechnology. That is to say, building robots the size of bacteria and viruses. The computers would start improving themselves in successive generations increasingly fast. This would somehow get us to the point of instant wish fulfillment. Whatever problem you want to solve, illness you want to heal, product or state of being you even imagine would just manifest completely, magically, like the sentence completion in a Google search. Want a flying car? Poof! A fly-sculpted youthful body? Poof! Molecular recycling? Poof! But I'm not here to praise the singularity. I'm here to bury it, so we can stop wasting our time and start building Edenicity. I started down the path toward Edenicity around 2004, when I began the research for a book I wrote about space habitats. I wanted to understand how to replenish air, water, and food for people living permanently in space. So I had to learn about soil. Soil is dangerous. Soil blew my mind. Soil changed the course of my life. I was seriously schooled by soil. To explain what happened, I need to use scientific notation. Here's how it works. 10 to the third power, or 10 to the 3, means a 1 followed by 3 zeros, 1,000. Now 1,000,000 is a 1 followed by 6 zeros, 10 to the 6, or 1 million. Similarly, a million millions, or 10 to the 12th power, is a trillion. In my book, I reported that a handful of soil, in addition to the mineral components, the clay, silt, sand, and pebbles, you can also find a vast living component, up to 10,000, or 10 to the 4, different species of fungi, protists, bacteria, archaea, and algae. I'm not even counting the viruses, which are vastly smaller. Collectively, I'll call these various microkingdoms of life microbes. And there's 10,000 of them in every scoop of soil, or so I thought at the time. Later on, I learned that that's about how many species you'll find in heavily worked garden or farm soil. By contrast, in pristine forest soil, you'll find more than 1 million, or 10 to the 6, different species per scoop. This is according to a paper that appeared in Science magazine, August 6, 2005. Now that's species, not individuals. There will be trillions, a few times 10 to the 12th of those in every scoop of soil. 1 million different species. Can you even grasp the enormity of this idea? Picture all the different kinds of plants and animals that live on a whole continent. Imagine every kind of sparrow, jay, hawk, goose, chicken, or owl you ever saw, plus 2,000 more bird species. Every ant, bee, wasp, beetle, or assassin bug you ever saw, plus 164,000 more insect species. Every spider, tick, or mite you ever even heard about, plus 4,000 more species of arachnids. Every kind of lizard, snake, turtle, or alligator, plus 111 other reptile species in toto. Every frog, toad, newt, and salamander, plus 300 more amphibian species. Every minnow, eel, bass, or trout, plus 1,000 more fish species. Every crab, lobster, crayfish, or barnacle, plus 4,400 other crustacean species. Every slug, snail, clam, oyster, squid, sea hare, or octopus, plus 50 more species of mollusks. 76 species of worms, 31 species of freshwater sponges. All the rats, mice, shrews, squirrels, deer, bison, cows, horses, wolves, mountain lions, manatees, dolphins, whales, and humans, plus 480 other mammal species. All the ferns, mosses, and grasses, all the vast meadows of wildflowers in a kaleidoscope of colors, petals, and clusters, all the ornamental garden flowers and ground covers, all the shrubs and evergreens and deciduous trees and vines you ever saw, plus probably another 20,000 species of plants you probably haven't even seen yet. Can you hold all of that in your head? Now multiply that by 5. That's how much biodiversity you can hold in miniature in a handful of soil. Now that's healthy soil, and it's getting harder to find. Soil that's been subject to pollution, tilling, and worked over with Miracle-Gro and Roundup for a few years will probably lose 99% of its species. It's virtually dead. In healthy soil, the various species feed and clean up after one another and process leaf litter and other waste into rich humus. Healthy soils can hold on to some nutrients 1,000 times longer than dead soils. As a result, wild, edible plants can thrive for thousands of years in the same spot without a trace of pesticides or fertilizers. In other words, this thing that we treat like dirt is actually the greatest life support system ever made. It's ultra-advanced technology. Now, if that seems hard to believe, let's compare an iPhone to a soil microbe. Microbes eat, grow, reproduce, and share all sorts of genetic information with each other. Not so an iPhone. When it needs a charge, it doesn't prowl around your house searching for alternative power sources. It doesn't make copies of itself. You can't cut a piece of it off and bury it like soil mycorrhizae, which is a fungus, and grow 2 or 3 new phones. And it's not really part of a community. When your iPhone dies, the other gadgets, the TV and toaster and so forth, do not spontaneously close in and recycle it. Though you can send it to Apple where Daisy, a disassembly robot the size of a house, may reclaim some of its components and materials. For half a century, computer scientists have worked on this thing called artificial intelligence. The idea was, if you build a computer that can store as much information as the brain, it should be as intelligent as the brain. Even 30 years ago, computers had a megabyte of RAM. They should have been as smart as a bumblebee. Now most smartphones have gigabytes of RAM. They should be as intelligent as a bird, but they're not. Not even the most sophisticated robot with millions of times the computing power of a smartphone can navigate an environment as complex as what a bacterium faces every day. A bacterium which has absolutely no brains at all. Clearly, the information model of intelligence is flawed. In 2004, Jeff Hawkins, inventor of the Palm Pilot, came up with an alternative model. He suggested that intelligence isn't how much you know, it's how well you can predict and respond to what's happening. I think he's onto something. From this perspective, life embodies massive intelligence. You can observe this intelligence on all scales, from the tiniest soil bacterium to the largest bioregion, from the present moment through generations of evolution. Maybe you heard about Watson, the computer that in 2013 won against the best human Jeopardy players. But without reprogramming, could Watson play chess or Wheel of Fortune or even Deal or No Deal? I guess I'm dating myself. Now, Watson can learn by pulling in vast amounts of information and by running billions of simulated games. This is somewhat like how I used to debug my astronomy apps for Palm Pilot. I used a simulator that ran my app and randomly hit all the keys and controls millions of times in a random sequence. I used this to validate the app, and though it worked great, it wasn't perfect. Hardware quirks and other installed apps would sometimes crash it, even after the most stringent testing. But still, it's plausible that Watson could learn to play other games or even drive a car. But what if you asked Watson to rewire itself, molecule by molecule, using a different element? I don't mean just list the parts for somebody else to assemble. I mean actually grow the tools and rebuild itself. Could it do that? Of course not. But that's exactly how creative soil life can be. In 2010, scientists isolated bacteria they found growing in arsenic-rich mud in California's Mono Lake. They cultured the bacteria in sealed containers and gradually removed all the phosphorus. Now, phosphorus is a macronutrient found in every living cell on the planet, including your body and mine. But it took the bacteria just a few months to substitute arsenic for every atom of phosphorus in its entire being, including its DNA. While scientists watched, the bacteria evolved into a life form with a chemistry different than anything previously found on Earth. In so doing, it showed an awesome capacity to respond to changes in its environment. By Jeff Hawkins' definition, these brainless little critters showed phenomenal intelligence. This was published in Science magazine December 12, 2010. The first function of design, as I mentioned in episode 5, is to embody intention. A cell phone embodies the customer value of connection and access, anywhere, anytime. But it also embodies the corporate values of steady revenue stream, competition, and obsolescence, which is necessary to increase the frequency of repurchase, multiplying that ever-important bottom line. So as I was writing my book, I gradually began to realize that our intentionally disposable technology would not last long in space. The only self-renewing technology we have ever known is life itself, and I think by now I've demonstrated that its design embodies a vast intelligence. The question is, whose intelligence? Maybe you've heard about intelligent design. To many of us, it's a comforting thought. If every body, big and small, were designed by someone, then our lives embody that someone's intentions. In other words, we were made for a reason. Our lives have meaning. How comforting to know that we are not an accident. But there's a flip side. If we were made for someone else's reasons, then can we have reasons of our own? If everything is predestined, how can we have free will? Well, maybe the point is moot. The design of even the simplest soil microbes, let alone a human being, embodies so much intelligence that it can be hard to see how it could have happened by accident. I've heard a lot of people say this over the years. And the linkages between the species seem just too perfect. They all fit together as a self-sustaining system. How could it not have all been designed on purpose from the beginning? But that's not how design works. As I observed in episode 5, design never happens all at once. And as we'll see, this is why self-improving computers won't be hitting a singularity anytime soon, anytime ever. Every gadget ever invented required development, which boils down to two things: repetition and variation. You design something, test it, tweak it, test it again. Repeat and vary. Working this way, it took Thomas Edison 10,000 prototypes, or 10 to the 4 prototypes, to perfect the simple light bulb. The Mono Lake experiment highlights something that plant and animal breeders have known for thousands of years. Life has the capacity to reinvent itself to suit changing conditions. It wasn't all invented at once. It's still under development, and in some cases, we have long played an active role in shaping it. The ecologist H.T. Odum writing in the American Biology Teacher back in 1963, portrayed each soil microbe as a little experiment in life support. In his view, every bacterium is under life and death pressure to efficiently find food, resist disease, or dehydration, or heat, or cold, or toxicity. Each member of a given species repeats a basic design, but each member also shows slight individual variation. Some variations help a microbe, or its species, or species on which it depends, to thrive where it happens to be. Other variations do not. Helpful variations survive, and the design evolves. Thus, from one generation to the next, microbes become not only more adapted to their current environment, but also gradually more adaptable to changing conditions. Repetition and variation build many layers of intelligence into their design. At some point, I wondered how many microbial experiments have gone into building the living world around us. Keep in mind that each of these experiments is really a little life. It's way more complex, with millions of times more variables and connections to its neighbors than any laboratory experiment, and there's relentless pressure to optimize every variable at once. But just to keep things simple, let's ignore all that and simply ask how many little lives have gone into developing life as we know it today. Well, even average soils have something like 1 trillion microbes per hand-sized scoop. Assuming an average soil depth of half a meter, planet Earth has something like 10 to the 20th scoops of living soil. The geologic record says life has been around for 3.8 billion years, or 3.8 times 10 to the 9th years. There are roughly pi times 10 to the 7 seconds in a year. Multiply that together and divide by the 3,000 seconds or so that the microbes live on average, and you get 10 to the 45 little lives. How does that stack up to human invention? Well, there are maybe 5 million active patents today, though most are just improvements on earlier inventions. But let's be generous and say humans have invented a total of 100 million devices throughout history. Now let's be ridiculously generous and assume that the average invention required 1 million experiments to perfect. So that's 10 to the 8th inventions times 10 to the 6th experiments equals 10 to the 14th experiments. So humans have conducted at most 10 to the 14th experiments to produce the manufactured world around us. Soil, however, embodies 10 to the 31 times more experiments of much greater complexity. Now I realize that's a hard number to wrap your head around, but let's try. Suppose you could record all 10 to the 14th human experiments throughout history together on a single grain of sand. How much sand do you think you would need to record all 10 to the 45 experiments that went into building the soils of the world? The answer is a pile of sand as big as the Earth. Life is Earth's most advanced technology, and most of it resides in the soil. Human invention, which is already depleting Earth's resources, will never catch up. But did you notice something? The massive development that went into creating the living world was a group project. Maybe it began on purpose, maybe it began by accident, but once it did begin, all it needed to become stupendously intelligent design was the free will of every living being, the will to live and interact, multiplied by generations of evolution over cosmic time. This evolution is nothing like Watson the computer running billions of simulations in the dark. Remember, each tiny life is not just a single experiment. It's a series of complex interactions over time in a complex and changing environment that includes many other living things, optimizing and evolving better relationships across a wide range of scales. Our physical lives are part of this story, too. We're part of something vastly intelligent, wonderful, mysterious, and unfinished. We are interconnected in far more ways than science can ever know, though we should always strive for deeper knowledge. We evolved along with it, and we belong. We belong to an ongoing creation, and our first duty is to the totality of life that sustains us. In a land ecology, that means our first duty is to the soil. It's a wet Ohio April as I record this. Every time it rains, the soil wakes up a little. You can smell it. Nearly every human being can. It's one of the most recognizable and pleasant smells in the world, and it's so distinct it has a name: petrichor. Petra from the Greek word for rock, and ichor from the blood that ran through the veins of the ancient Greek gods. Petrichor is a combination of chemicals, the main one being geosmin, a byproduct of the actinobacteria that decompose leaves and other organic matter in the soil. Humans can smell geosmin at 5 parts per trillion. In other words, we can smell it 1,000 times more than we can smell the ammonia in smelling salts. This is no accident. It's been integral to our survival over vast swaths of our evolution. We live in perilous times. Environmental problems abound, as do techno-shortcuts and techno-fantasies. That's why it's time to wake up and smell the petrichor, the signature of the highest technology we will ever know, and our most precious resource. In the next episode, I'll discuss how civilization after civilization squandered that resource and fell, how soils are even more imperiled in the modern world, and how Edenicity will reverse these trends, laying the basis for a permanently wealthy civilization. If you enjoyed episode 13, please be sure to subscribe so you don't miss a show. If you haven't already done so, please visit the news link at Edenicity.com to download a copy of the reference design. Until next time, I'm Kev Polk, and this has been Edenicity.